Welcome to Magic Academy. We are looking at Alkyne Homologous series. Alkyne Homologous series. If you can recall, we have done Alkane. Now, it told us that basically we have three families of organic compounds. We have alkanes, we have alkenes, and now alkynes. These are basically three families of organic compound. Every other one we'll be discussing will now stem from alkane. Just as I told you earlier, alkane is highly saturated hydrocarbon. It's a saturated hydrocarbon. In the sense that the carbon, remember in organic chemistry, we are studying carbon compound. So, like I always tell my students, in organic chemistry, focus more on carbon. So, in alkane, just a recap. For alkane, the carbon to carbon bond is single, just as you are seeing here. The bond holding one carbon atom to another is single. And that's what gives alkane their saturated state. Then remember this alkane, they have the formula of CnH2n plus 2. It is their general molecular formula. And of which you know from a general molecular formula, you can derive the whole members of that family. Don't forget what we define homologous series as. Homologous series is the family of organic compound which follows a regular structural pattern by which each successive member differ by a CH2 group. So from this general molecular formula of alkanes, the whole members of alkane will be derived. Like you can put N equal to 1 here to get the first member, which is methane. When you put N equal to 2, you get the second member, which is ethane, and so on and so forth. The video is there for you to watch again. Now, alkenes. These alkenes are generally known with their double covalent bond. That is to say that the bond holding carbon to carbon is double, just as you can see here now. Carbon to carbon double bond. Even though this one I have written, is it a di-ene? Don't worry, get it. Just carbon to carbon bond is double. Anywhere you see a compound with a double bond holding carbon to carbon, not just with a double bond, you can have alternate double bonds. But if you notice a double bond anywhere around the ring, note that it belongs to alkenes. And I say this double bond confers a degree of unsaturation. Is unsaturated hydrocarbon. So alkenes are unsaturated hydrocarbon. These are just a recap. You have the video there. You may have watched it before. Now, going to the one we have today. Okay, the formula for this alkene is still CnH2n for alkenes. The important thing here, note their general molecular formula. It is from that general molecular formula that the whole members will be derived. Now, take alkyne, which is the topic for now, for today. Look at the general molecular formula CnH2n minus 2. I said something when we were discussing this one on the last video. I told you that the simplest form of alkane starts with N equal to 2. The first member doesn't exist, it is too reactive. So that is why the first member is presumably alkane. Alkane. Okay, the same thing happens here. This one is known by the presence of triple covalent bond. So when you notice, remember organic chemistry, the study of carbon compound. It's not that other substance groups are not important, but our primary purpose in organic chemistry is just carbon compound. Now, if you notice anywhere around the carbon to carbon chain and you see a triple bond, triple covalent bond, this thing will tell you that we are talking about alkyne. Don't forget what we said about homologous functional group. Functional group is that thing that indicates where a compound belongs to. Like I have told you, anywhere you see double bond, take your mind to alkane. Anywhere you see triple covalent bond, take your mind to what? Alkyne. So we are going to learn how to derive at least first three members of a alkyne. First three members of alkyne. Let us see how it goes. To get the first member of alkyne family, put n equal to 2. N equal to 2. That means anywhere you see n in the formula, general molecular formula, you put 2. Look at how it goes. Look at the general molecular formula. So anywhere we see n now, we put 2. C2H. 2 times 2 minus 2. I have substituted anywhere I see n, I have put 2 there. And of which mathematically 2n translates to 2 times n. So this thing becomes 2C2H. 2 times 2 is 4. 4 minus 2 is 2. 4 minus 2 is 2. Don't forget that the structure of this thing is like this. It's linear. This is what we call the first member, and the name is what? Ethyne. Ethyne is the simplest form of alkyne. Ethyne. C2H2. Look at the functional group there. Functional group, what will take you to where it belongs to? This is ethyne. So the second member, put n equals what? 3. So anywhere you see n in the formula, you put 3. So C3H2 times 3 minus 2. From general molecular formula, I have subtracted n for 3. Look at it very well. So this becomes C3H. 2 times 3 is 6. 6 minus 2 is 4. The name of this compound is propine. Propine. And the structure goes like this. Look at it now. For now, we are not dealing with how you pack nomenclature of this thing. So you can put your triple bond anywhere you feel like. For now, until we get to that you pack, you understand the importance of the position of the functional group. You understand the importance of the position of the functional group when we get to how you pack. So this is the structure of propine. So if you want to get the next member, make n equal to 4. Make n equal to 4. So anywhere you see n in the formula, you put 4. C4H2 times 4 minus 2. C4H 2 times 4 is 8. 8 minus 2 is 6. And the name of this thing is time. Don't forget the naming. Don't forget the naming. The suffix of the name will carry the suffix of the parent. Don't forget the parent has Y and E. So the name of this thing, in fact, alkyne is named by replacing the E ending of alkane with Y and E. Just check this. Alkane, when you remove the E ending, or when you remove the N E ending here now, when you remove this thing now, you are going to get alkyne. So you are going to remove A N E. There you substitute it with what? Y N E. That's how to name it. So if you watch, this thing now becomes 1, 2, 3, 4. Like I told you earlier, you can put your triple covalent bond anywhere until we get to the back. You understand actually where the position of this thing affects. So this thing goes like this. If you watch me, I don't even count my hydrogen. Since I've done what I'm supposed to do, I am okay. I don't even count number of hydrogen, but if you count it, it will still be ballast. This is a butane. And so on and so forth. If you want to get the next member now, put n equal to 5. So anywhere you see n in the formula, the general molecular formula of alkyne, you put 5. From there, you get all these things. I gave you the prefixes. Let me repeat. In organic chemistry, anything that has C1, the prefix is mate. I'm putting this thing now to tell you that a suffix is coming. C2 is earth. The suffix is coming there. C3 is pro. So that you will not be confused. How am I getting the names? Butane, ethane, propane. So you know that it is according to the number of carbon that compound contains. So C4 is bot. 5 pent. C6 is hex. C7 is hex. 8 is out. 9 is non. 10 is deck. 11 is on deck, and so on and so forth, etc. So these are the prefixes for naming organic compound.